everybody, it's Mrs. Harbin. Good news, video note 7.3. Bad news, I don't have any music today. What's up with that? Well, without the music, let's get started. Give a balanced chemical equation. Make sure you can identify what the limiting reactant is, explain significance of percent yield, and calculate stuff. So here we go. All right. Make sure that you look at the book, read section 12.3 to understand this. All right, so here's a definition of limiting reactant. A limiting reactant controls the amount of product formed. So what does that mean? Well, if you have 6 slices of bread and a whole fresh sliced ham roast, how many ham sandwiches can I make? Well, with 6 slices of bread, no matter what you do, you're only going to get 3 sandwiches. All right, so the bread gets used up. So this is called the limiting reactant because it determines how many sandwiches you're going to get. So it's 6 slices of bread. You need 2 slices of bread for every 1 sandwich. All right, then that means you're going to get 3 sandwiches no matter what you do. Okay, if you have ham, lots and lots of ham, you're only going to get 3 sandwiches. So here's what you're finding out. The reactant that gets used up is called the limiting reactant. The limiting reactant determines your maximum amount of products you can make. So you can make 3 sandwiches at most with 6 slices of bread. This is called a theoretical yield. In theory, I should get 3 sandwiches. Okay. All right. So what's the limiting reactant here? Well, we have red atoms and green atoms. So we look from left to right, and we notice that 1, 2, 3, 4, 5, 6 products form, and all of the green atoms get used up. So the limiting reactant gets used up, and determines how much product. All right. What do we call the other reactant? Well, the other reactant is called excess reactant. The excess reactant or excess reagent is a reagent that has some leftover. All right, so how do we know the red has some left? So the excess reagent, so the ones I'm circling, all right, this funny looking shape shows you the excess reactant. It's some that's left over. Okay, so here's some more definition stuff. The limiting reactant or reagent is a reactant that controls the amount of product. The excess reactant is the leftover reactant when the reaction is done. So some of the excess gets used up, but some of it gets left over. So here's a balanced equation, and these represent the nitrogen, these represent the hydrogen. Okay, so every time one of these gets used up, we need to use up 1, 2, 3 of those. One of those gets used up, 1, 2, 3 of those. So we end up with 4 products, all right, and this is excess nitrogen. Okay, so limiting reactant, the limiting reactant was the H2 because there's none left over. Excess reactant was N2. Okay. All right, so it's your turn. All right, so we got some hydrogen, some oxygen. I'm letting you think about it. Pause the video right now and determine what the limiting reactant is. This is oxygen. This is hydrogen. All right. Every time one of those gets used up, 2 of those gets used up. 1 of those, 2 of those. We're out of oxygen, and we have 2 hydrogen left over. So here's our product. All right, H2Os, right, and this is excess. So hydrogen was hydrogen because there's leftover. The limiting reactant was O2 because from left to right, the O2 gets all used up. All right, so how do we calculate the amount of product? Well, once you know the limiting reactant, you calculate the amount of product that can form. Okay? The amount of product that formed using a calculation is called stoichiometry. You use stoichiometry. It's called a theoretical yield. All right, if you think about the sandwiches I was talking about earlier, the limiting reactant bread gave us maximum 3 sandwiches. That's a theoretical yield because you use a calculation. All right, so now we're going to do a percent. The percent we're talking about is percent yield. Percent is always part over the total, but times 100. Okay, but in a percent yield, the parts is what you got in the lab. It's called your actual yield or amount. Okay, the total, what goes on the bottom, is what Stoich says you should have. So that's called a theoretical yield. so now we're going to do a definition. Theoretical yield. All right, so percent yield is equals the actual yield, which is the part, it comes from a lab, or it's given in the problem, divided by the theoretical yield, which is a calculation that comes from stoichiometry, times 100. All right, so percent yields, actual yield, given or from lab, and theoretical is calculated from stoich. Okay. All right, so percent is always part over total times 100. All right, the part in percent yield is actual, total is theoretical. All right, so calculate the percent yield. Oh, I need to find percent yield. If 85 grams of CH4 react with excess oxygen to make 175.34 grams of water. Okay, so percent yield. You need actual yield over theoretical yield times 100. Actual yield comes, it's product, so this is actual. All right, so we need 175.34 grams of H2O over the theoretical yield. What? We need a theoretical yield, so we got to fill in this number. All right, times 100. Well, how do you do that? Well, you start with the limiting reactant, and since there's excess oxygen, this is limiting, and you use stoichiometry. So we have grams of CH4 and moles of CH4, and then CH4 has to turn into H2O, and the only place we can do that is in moles to moles, and then moles of H2O have to turn into grams of H2O. Alright, so how do we figure out the numbers? Moles and grams, you go to the periodic table, 1 mole equals 16.05 grams. Moles to moles, you have to use a balanced equation, so we need a 2 for the H2O and a 1 for the methane. Okay, and then grams to moles, moles are 1 mole has 18.02 grams periodic table. Bye grams of methane, bye moles of methane, bye moles of water, and we find out that we get 190.87 grams of water. Now, this is called a theoretical yield. We didn't do a lab experiment, we just figured out what should form, and so that goes there. So that's the 190.87 grams of H2O. Okay, so 175 divided by 190.87 equals, the percent yield is 91.86% yield of water. Okay, so percent yield, actual over theoretical. Actual comes from the problem or the lab. Theoretical comes from stoichiometry. All right, we have this reaction, and we say, what is percent yield? So again, percent yield is actual yield over theoretical yield times 100. All right, where does the actual come from? Well, it has to be product. Okay, 4.8 grams. 4.88 grams of copper form in the lab. So now we need a theoretical yield. Well, we have to do stoichiometry to get that. So we need to say, all right, I'm starting with 1.85 grams of aluminum. I need to change grams of aluminum into moles of aluminum. I need to change moles of aluminum into moles of copper. I need to change moles of copper into grams of copper. And this is going to be, if all 185 grams reacts, how much copper should come out? 1 mole, 26.98. If you said periodic table, you're right. Moles of copper holds 2 different kinds of moles. We use the coefficients, 3 and a 2. Okay, and then moles to grams, periodic table. Alright, so we get 6.54 grams of copper. Now this is called a theoretical yield because we just did stoichiometry to find it. So that goes down there, 6.54 grams of copper. And then when you divide this out, you get 74.62% yield of copper. Okay, all right, can we do more? Sure, we could do more. But you might be wondering to yourself, why don't I get 6.5 grams of copper out of this reaction? Okay, why is what you actually get in the lab different from what you predict using stoichiometry? Well, here's why. In order to react, particles have to collide. You have to collide to react. Now, what if not all the particles collide? Then they're not going to react. All right. Some reactants and products have transfer issue. Okay, so if we want to get this out of the container, we have to make sure it all comes out, but sometimes things stick to the side, so you don't get it all out. Okay, and then side reactions take place. So maybe you want to react, but then, or maybe you don't collide, or maybe you're colliding with something else that's in the container. Okay, so to review, limiting reactant is the one that gets used up and determines how much product you get. Make sure you know that definition. Percent yield equals, percent is always part over total. Make sure the total is from stoic and the part is from a lab or it's given. Okay, always go through moles. Thanks for playing. Please read section 12.3 and make sure you can do all these things and you learned what you're supposed to learn. I guess I can sing for you. That's the end of video note 7.3. Isn't this a fabulous